know that we struggled a lot with the Chapter 6 test, and since there's going to be a little bit more in the way of Chapter 6 of a final exam and the other chapters, I thought it would help us if we went ahead and reviewed a few more problems. And so in section 6.1, I pulled out a problem that I thought would be, it involved some of the issues I saw when we were working these problems out in class yesterday. Whenever you see a problem with the variable on the right-hand side of the equation, go ahead, if it helps you, and maybe make the first thing you do, turn the whole problem around. Just don't forget to turn the inequality symbol around with it. And let's understand this to mean this: x minus 1/5 greater than or equal to 4/5. Now we're going to add 1/5 to both sides here to try to solve for x, right? So when we do that, we're going to end up with x greater than or equal to 4/5 plus 1/5. That's equal to 1, so that you should say this. This is the algebraic, solution here. All the values of x greater than or equal to 1. On the number line, just make sure you're shading in the proper direction. Make your origin. To the right of the origin is the number 1. The presence of the equal sign ensures that we should be using a filled-in circle. Be clear about that. And since the arrow points to the right, shade to the right, and that's how you would graph it. In 6.2, the problem is 7. This is a 7 right here, okay? That's a 7. Less than a negative b over 4. Now there's several things going on here. First of all, let's turn this problem around like we did the previous. So the variable's over on the left-hand side, but turn the inequality symbol around with it. All right? Now this is a negative b over 4. Whenever you have a negative associated with a variable, know this: you're going to have to multiply both sides by a negative 1, which is going to turn the inequality symbol around. And we've also got to multiply by 4 to get rid of that 4 in the denominator. But if we go ahead and multiply both sides by a negative 4, taking care of both issues at one time, all right, and what we're going to end up with is b, not greater than, but less than a negative 28. Algebraic answer. You graph this, establish your origin. I'm going to move my origin a little bit further to the right. Since now I'm going to be shading to the left, I know that a negative 28 is to the left of the origin. I want to give myself plenty of room to demonstrate graphically that I know how to graph this. I'm not going to move too far to the left of the origin to indicate where I'm going to say the negative 28 is going to be. Because if I come all the way out here, let's say, I don't have much room to shade, do I? So I'm just going to go ahead and move in right here and call this where negative 28 is. Open circle. Make sure it's open. Then shade to the left all the way to the arrow, okay?
So if they don't say that, you ain't no count.
If you do this, but not the other, I'll give you half credit, but that's all. Go ahead and graph it and get full credit. Make sure everything is
if they graph it, and then how you shade that in, but if they don't shade that in, that should be cool thing.
What if they did shade this in? Is that what you mean?
No. It's right.
What's that? Oh, if they don't shade, yeah, I'm not going to, you're only going to get half credit. You've got to indicate the shade. So all you do is write the number line and indicate the point of the number line where the interval starts, but you don't tell me which direction, which side of that point. That's not enough information, okay? Now, going on to 6.3, let's spend a little more time here on 6.3. This is one of these compound inequalities. And remember, compound inequalities fall into two categories. They're either going to be an and or they're going to be an or. This one, you should be able to recognize as an and, right? This one is an and. So, as such, these are easier to solve because you can solve them simultaneously, all three parts at the same time. I'm going to subtract 8 from all three parts of this inequality. All right? I've got to get y in the middle by itself. Remember, you read these from the inside out. When I subtract 8, I get a 4 here, right? Then a negative 4y in the middle. It's going to be an interesting situation here. And then a 16 minus 8 is a positive 8, right? But what am I going to divide by? Negative 4. Now, what's that going to do to the entire inequality? It's going to turn both symbols around. So when I divide, the negative 4. What I'm going to end up with, negative 1. Got to turn it around. Y in the middle. Turn it around. Negative 2. Yeah, go ahead and graph it here. So, and it's still going to graph much the same way, okay? Both values, the endpoints on this interval are both negative. I'm going to put my origin here. We've got, here's a negative 1. Open or close circle?
Open.
On
Close.
here, it's going to be closed. What about the negative 2? Open circle. So we want the y values that are greater than a negative 2, less than a negative 1. So we're still talking this here, okay? Does that make sense?
Yes.
All right. What happened? All right. There we go. All right. Now I want to do an OR here. All right, we're going to do this one now. This one is an OR. Okay? Sometimes ANDs are referred to as intersections of solution sets, and ORs are referred to as unions of solution sets. But we're going to have to solve both of these equations individually here. No shortcut method here. So the first thing I want to do is subtract 2. So I get 3x greater than, when I subtract 2 here, it's going to be a 9 here. Dividing by 3, x is going to be greater than 3. Or, dropping the parentheses gives me this here, right? You see this? The 9, when I subtracted 2 from 11, 11 minus 2 is 9, then I divided by 3 to get 3. Now coming over here, the first thing I had to do is drop the parentheses. When I do the negative out here, changes this to a negative 3x to negative 2 to a plus 2. Yeah, subtract 2. Negative 3x is greater than 2. Now what am I going to divide by? What's that do to the inequality? Yeah, it's going to change it. Okay? So, what we're looking at here, when I graph this thing, origin I'm going to put in the middle, since one of the endpoint values is negative, the other is positive. The negative one, negative 2/3, x less than that, open circle, x greater than 3, here, open circle again. That's what this one looks like. When we do what? Drop the parentheses. If there's a negative in front of it, then change the sign. Okay? All right. On this one here, 3t plus 2. This is problem 56, okay? 56. Remember, with these absolute value equations, you've got 2 equations in one. We want all the values of 3t plus 2, where the value of t, when used in conjunction with the absolute value situation here, produces a 6. That means this. There's going to be some value of t, 3t plus 2, that equals a positive 6. But there's also going to be some value of t plus 2 that's going to produce a negative 6. All right? So what I'm going to do here is subtract 2 in both situations. 3t is going to be equal to 4 when I subtract 2 from it. When I subtract 2 here, 3t will equal to a negative 8. All right? Now divide by 3 each situation. And here, t is going to be equal to, I know it's an improper fraction. You can go ahead for purposes of these problems, leave it that way if that's the case. T is going to be equal to a negative 8/3 here. You should substitute these values into the original equation just to make sure that they work. Okay? This one is going to produce a negative 6. I'll put a negative 8/3 in here. The 3's will cancel. A negative 8 plus 2 is a negative 6. Then the absolute value, that's a positive 6. And 4/3 analogous to that, okay? You put 4/3 in here, the 3's cancel again, leaving you with 4 plus 2 is 6. All right. Okay, problem 66. The absolute value of 3x plus 3 less than 0. What's the answer here?
You got an answer.
The absolute value of 3x plus 3 less than 0. What's the answer? Again, let me ask this again. The absolute value of 3x plus 3 less than 0. No solution. Because if it's less than 0, it's going to have to be negative, and it's never going to be negative.
No,
So no solution. Be on your guard here, okay? All right. All right, this is going to be the last one I want to do today. Absolute value of p minus 13 greater than or equal to 3. Now, with the inequality symbols, depending on the direction that they point, this thing is either going to behave like an and or an or when it comes to compound inequality. How is this one going to behave? Like an and or an or? Is it an and or an or? It's an or. How do you know it's an or? Not because the equal sign. Why? Because of the symbol, right? If it's a greater than symbol, it behaves like an or. If it's less than, it's going to behave like an and. That's the difference. So this one is an or, and I'm going to work this two ways. First, as it is in the text, as an or. And what I'm going to do is I'm going to say p minus 13, I've got to come up with two equations. Okay? Turn that around and make this a negative 3. Okay? Now, over here, when I add 13 to both sides, p becomes greater than or equal to 16. When I add 13 to both sides, p becomes less than or equal to 10. So when I graph this thing, all right, we've got, going to put the origin over here to the left. 16, we'll say is right here, fill in the circle, heavily shaded to the right. 10 might be right here, filled in circle, shade left. Okay? Now, so this would be the issue, the problem, the answer. Now, if the problem read like this, p minus 13 less than or equal to 3, would this behave like an and or an or? This one would be an and. Same essential problem, I just turn the inequality symbol around. You still make two equations. All right. So what I'm going to do here is this. This is a 3 here, right? So add 13 to both sides. P less than or equal to 16. Here, P is going to be greater than or equal to, when I add 13 to both sides, 10. So when I graph this one is going to be graphed. So behave like an and. So here's 16. Here's 10. Greater than 10, less than 16 puts me in here. That would be the difference in the way that these two would graph. All right? You will see, you don't have to do it both ways. I just wanted to do basically the same problem with the greater than symbol then with the less than symbol, so that you can see the basic difference in how an and or an or behaves. Okay? Because that's the only difference in the two problems is where the inequality symbol is pointing. So I would like the answer formatted like this with P in the middle, 10 here, 16 there. All right? That would be the answer. Okay, that's going to wrap things up for our Chapter 6 review. Make sure that you go ahead and I want you to view all of these videos between now and Monday. I want the chapter reviews 1, 2, 4, 5, and 6 turned in Monday. And you must have your textbook with you as well. All right? Okay.
I said 1, 2, 3, 5, 6.
You've already turned in Chapter 3 review. It was Friday work last week. So you only 1, 2, 4, 5, and 6 reviews.